Okay, so in this video, I'm going to show more examples on how to find the nature of the roots of the quadratic equation ax squared plus bx plus c equal to 0. So just for a quick review, to determine the nature of the roots, we need to know the value of the discriminant, in which the discriminant is b squared minus 4ac. There are three cases, again, so this is just a review. When b squared minus 4ac is less than 0, a negative number, we say we have no real roots. But it's possible that you have roots, except that those roots are not real, meaning they could be imaginary numbers. Okay, and that's a totally different set of numbers from the set of real numbers. So when the b squared minus 4ac is a negative number, it means less than 0. For example, you got a b squared minus 4ac equals negative 2. Then that means in the given quadratic equation where you got this value of b squared minus 4ac, then we could conclude that there are no real roots. The second case is when b squared minus 4ac is equal to 0. When the b squared minus 4ac is equal to 0, the nature of the roots is that there are actually two real roots that are equal. Okay, so 2, let's just add the note that we have two equal real roots. Okay, so two real, at the same time they are equal. Now this statement can be simplified as just one real root. So meaning to say, when you solve for the roots, you're looking for those values of x, and say you ended up, say you're factoring it, and you ended up with x minus 2 equals 0. That means one of the roots is x equals 2, and also x equals 2 coming from the same factor. Okay, but we don't need to say two real equal. Sometimes we can just say it's just one real root because they're just the same. Okay, so two real and equal roots, that's synonymous to saying you have one real root. Okay, so far we have two cases. We have the less than 0, no real roots, and then b squared minus 4ac equal to 0, two real and equal roots. The third case is when b squared minus 4ac is a positive number, greater than 0. You solve for it, you got 4, that's a positive number. You solve for it, you get 10, that's a positive number. So what will be the conclusion? Well, we say there are two real, but these roots are not equal. So unequal or not equal roots. Not equal. Two real but unequal. Okay, when the b squared minus 4ac is greater than 0. Okay, so these are the things that we should know to determine the nature of the roots. And we call this b squared minus 4ac the discriminant. Okay, so let's take an unusual equation. Okay, because if we are given an equation of the form, say 3x squared plus 4x plus 7 equal to 0, this is in the form of ax squared plus bx plus c equal to 0. It's actually easy to find the b squared minus 4ac value. Okay, but not all equations will be written in the form of ax squared plus bx plus c, or are not written in this form. So there are things that you have to do first in order for you to get this form of the quadratic equation. Okay, I'll show you one example. Okay, so let's have this equation x minus 11 minus, or say x times x minus 6 is equal to 0. So let this be our example 1. So as you can see, this is not yet in the form of ax squared plus bx plus c. The key is to simplify the given expression. Okay, and to simplify means we rewrite this as x minus 11. We remove the parentheses. Then we do proper distribution. This becomes minus x squared, and then this becomes plus 6x, and the other side is still equal to 0. And then arrange the expressions so you can have negative x squared. So it's your negative x squared, and then x and 6x will become 7x, and then minus 11 will stay as minus 11. Now to easily use the b squared minus 4ac, for me, I prefer making the x squared positive x squared. So what I will do is I will multiply both sides by negative 1. And this will become, the effect will be, this is now x squared, the plus 7x is minus 7x, the minus 11 becomes plus 11. The signs will be reversed. Well, 0 will stay as 0. Okay, now that the equation is of the form ax squared plus bx plus c equal to 0, we are now ready to find the b squared minus 4ac value. So identifying my a is 1, that's 1. My b is negative 7, it's here. And the c is equal to 11. Then plug in the values. Well, make sure you use a parenthesis because the value will become different if you don't use a parenthesis when you substitute. Okay, so here you can see negative 7 squared minus 4 times a, that's 1, and then c is 11. Compute this value. This is 49. 4 times 1 times 11 is 44, so minus 44. 49 minus 44 is equal to 5. From here, you make a conclusion. This is greater than 0, a positive number. So the conclusion is the equation, so it has two real roots that are unequal. Okay, by the way, in some books, they say this as two distinct roots. So they're not equal, so they're distinct, real, because they're real, and then roots. Two distinct real roots. Okay, because b squared minus 4ac is 5, and 5 is greater than 0. Okay, let's take a look at one more example. So suppose I have, let's think of a good example. X minus, let's say we have 2 over x minus 1 equals 4. Let's see we have this one. So this is example 2. So again, this is not yet of the form of ax squared plus bx plus c equal to 0. So we have to find a way, and we can do that if we can eliminate the denominator x minus 1. This one, we need to eliminate this. Now we can simply multiply both sides by that factor. So x minus 1, and this will give us x with an x minus 1. See? X with an x minus 1. For the second, the x minus 1 will cancel with the x minus 1. So you have minus 2. And then on the other side, 4 will be multiplied to x minus 1. Then just continue, simplify x squared minus x, then minus 2 equals 4x minus 4. make one side equal to 0 so that it will be in the form of ax squared plus bx plus c equal to 0. So this is x squared minus x minus 2. You can subtract 4x and you can add 4 on both sides. Okay, so minus 4x plus 4. So this is minus 4x plus 4. The other side now is equal to 0. So again, just continue, simplify it. Minus x minus 4x becomes minus 5x minus 2, and plus 4 will become plus 2 equal to 0. Okay, again, our goal here is to find the nature of the roots. We're not looking for the roots. We just want to find the value of b squared minus 4ac. In this case, our a is 1, our b is negative 5, our c is equal to 2. So substitute properly. This is negative 5 squared minus 4 times our a is 1 and then our c is 2. So this will be 25, negative 5 squared is 25, minus 4 times 1 times 2 is 8, and this is 17. Again, a positive number. So this is, so we could say that the equation has, so it has two distinct unequal, distinct real roots. Okay, so that's the conclusion. So let's take a look on what we have done. These two cases or examples are the ones that will require some manipulation to simplify them in the form of ax squared plus bx plus c. We have seen two types, so just by applying distributive property, simplify it and transform it into an ax squared plus bx plus c, like in this example. And sometimes you have some denominators, and what you can do is to eliminate those denominators by multiplying both sides by those expressions. In this case, we only have x minus 1, so we needed only x minus 1 to be multiplied to both sides of the equation. Okay, so again, do not forget that there are three possible conclusions that you can have when the b squared minus 4ac is less than 0. We say there are no real roots. There could be roots, but they're just not real numbers. Sometimes when you compute for the b squared minus 4ac, it becomes 0, and that means there are two real roots and they are equal, or we simply say they are, or we have a one real root because they're just the same. And b squared minus 4ac is greater than 0, we say two real roots, or two real roots and unequal roots. Okay, now these statements can vary depending on how they are stated in a textbook and the way that the teachers will say it, but the idea behind these roots are just the same. There are two real roots, two real distinct, two real unequal, basically the same. Okay, so I hope you understand my explanation. That's for this video for now.